right, so this video is going to be about 1.3, which is graphing things using dot plot. It's graphing our data. So you'll notice I already have the definition written on the board. Dot plot is exactly what it sounds like. You're going to use dots to represent data. So what you do is it's going to show each of your data values as a dot above its location on the number line. Okay, now I'm going to talk to you about how we would draw that, and then we're going to talk about how you would describe them. And then you'll have an assignment in your sapling learning. All right, so we're going to draw a dot plot that has to do with the number of siblings that students in a class have. All right, in order to create our dot plot, we need to keep a couple of things in mind. The first thing that we need to do is we need to draw our axis and label it. Now, because the dots are going to represent the number of times something occurs, or the tally, or the frequency, we don't need a y-axis on our chart, we just need an x-axis, and that's going to represent what sort of data we're talking about. So when I draw and label, I'm going to draw and label my x-axis only. All right, so I said this is about number of siblings, so I'm going to go ahead and I'm going to draw a line. Now, you can also wait to draw the line until you know how many tick marks you want to put into it, because what might happen, and this happens to me all the time, is I might write them and then realize I ended here and I have all this extra space. Or I might start writing it and realize that my line doesn't go as long. So you might sort of take and combine steps 1 and step 2 together as you're doing this. You always want to make sure you label, because if you don't label, then people have no idea what your graph is about. All right, now that I have my axis labeled for the number of siblings, I need to think about my data. So I want to scale my axis. What that means is I need to think about my smallest data set, my largest data set, and then I need to make sure that I use equal intervals. So you don't want to look at it and have the intervals jump. Like, so say I'm using whole numbers, you don't want to go 1, 2, 3, 4, 5, 10, 20, 30, because you want it to be the same. So when someone looks at it, the graph makes sense. If you've ever watched any programs where they're doing graphing, you have to be really careful about the way that they label things, because you might see a graph, right, where the data looks really, really high in a lot of places, and then the next graph, it looks, oh, really, really low. But it turns out this is in, measures of 1, 2, 3, 4, 5, 6, and this is in measures of 10,000s. All right. If you have watched any of the recent COVID numbers, when they do it by county, you have to watch the scale, because some counties have a large number of cases and some have a small, and the graphs all look really crazy if you don't realize that they're differently scaled. So for us, like I said, we don't need a Y scale here because the dots are going to do that for us, but we need to think about the smallest data value and the largest data value, and then we want them to equally spread across our line. So for my data, this is data that was collected by someone else, right, from the textbook. This person, they scaled their class and they said, okay, we have some kids that have no siblings, and then we have some kids that have as many as 7 siblings. So I want to go from 0 to 7 on this line. Now, if your data is decimals, make sure you stay consistent. If you find that you have a number where you're like, it makes more sense to scale it where I'm not starting at exactly the right number and ending at exactly the right number, right? So maybe you want to start counting from 1, even though your first data point's at 1.3. That's okay, all right? That's totally fine to do. You just want to stay consistent. So I'm going to start at 0, 1, 2, 3, 4, 5, 6, and then see, this was my problem. I tried to stay really consistent across the board, and I'm not a computer, so I'm a little bit off, but I had to extend my line a little to hit 7. And then what we do is we say, okay, there were 4 people in the class that had 0 as a number of siblings. I like to actually come back after I do my tick marks, or if I can be really good about it, not draw them all the way through. It's easier to draw the dots when the line on top is flat. And I'm going to do 4 dots. I'm going to try to space them evenly, and I'm going to try to make them equal size. Remember, we are not robots, so if you're not perfect, that's okay. All right? All right, so then for one sibling, let's see, it looks like I've got about 9 people. So I'll go 1, 2, 3, 4, 5, 6, 7, 8, 9. Then for 3, I'm sorry, for 2, I have about 6. 1, 2. Now notice I got a little bit off here, so I might come back and erase it. You don't have to be perfect, just do your best. And for you guys, you're mostly going to be looking at these after they're already created and trying to read the data. All right, then I had 3 people that had 3 siblings. There were 2 people with 4 siblings. There was 1 person with 5 siblings. There was no one with 6 siblings. And then there was 1 person with 7 siblings. Now, this leads really well into us talking about descriptions of graphs. This is a really great dot plot, and if I asked you for data about it and I said, hey, how many people had 1 sibling? You could tell me. If I said, hey, how many kids in this class had 3 or less siblings? You could count 3, 2, 1, 0, all those dots, and you could tell me how many people had 3 or less siblings in this class. All right, so the idea of a dot plot is each dot represents one person that answered that way or one time that occurred. And this is a really good way to start talking about our data. Now, do you notice with this data, if I were to draw a line over it, see how it sort of has this high peak in the beginning and then scales down at the end? One of the things that we talk about is the shape of it. We talk where maybe the height of it happens, where the most data happens. We also talk about what is called a skew. A skew is when you have more data on one side than you do on the other. Okay, so I'm going to erase this right here. I'll pause for just a second if there's any part of it. You, of course, can pause the video if there's something that you want to write down. Then I'm going to erase it, and we're going to talk about how to describe dot plots. And then you can work on the assignment. There's about 5 problems or so in there. I tried to be really careful selecting problems that really fit to what we were talking about. If you have questions about any of them, make sure you make some time with me, either in my office hours or make an appointment for office hours. Okay, so find my eraser. All right. I'm not going to draw 3 different dot plots here so you can see symmetric right skew and left skew. I'm going to draw the line that would go over them so you can see the general shape. All right, so we have symmetric. If you've taken any sort of math class before, it's distinctly possible you've talked about symmetric or symmetry before. We have skewed to the right. And then, of course, we have skewed left. Okay, symmetric means that the data looks similar to right and left of center. And so when I draw that, it might look like, if I were to trace it, not with the dots, right, pretend dots are there. If I were to trace it, it might look a lot like that, which we call a normal distribution. So it'll generally look like a hill where the sides match. Now, it could be the opposite, right? You could have it, and it could look like this. It could be high here and then go down and then come back up. The idea is, if I draw a line down the center of my data, the right and the left-hand sides look the same. That's usually what symmetric is. We mostly see it looking like this, but it can look like that. As a teacher, you know that things are not going well in your class if this is what it looks like. You want everybody generally to be doing decently, as opposed to some people doing amazing and the equal number of people doing terribly. All right, skewed right means the right side is longer. Okay, so for example, this one right here would be skewed right, because do you see how it comes up really quickly and then goes on longer to the right? If we were to draw a point sort of right in the middle, right, we have this kind of long right tail. All right, so like I said, you would want to think of that sort of like this idea, where it comes up and then goes on longer to the right. Skewed left then, of course, means the opposite, where the left side is longer. And that would look something like this. Okay, so think of it almost like a ski slope would be a way to think of it, or a hill that you are going to skateboard on. You want to think of it as it skews towards the long tail. So if somebody were riding here, their right side would be kind of a longer, flatter slope, whereas here, that's sort of terribly skewed left. This should come up a little bit further in the left direction. But you can see what I mean to that. There's sort of a longer tail to start on the left-hand side, whereas here there's a longer tail on the right-hand side. Okay, the last thing that we're going to talk about is some different ways you would describe data. So I'm going to erase these. I'm going to leave this guy up, and we're going to talk about its shape, and we're going to talk about some of its characteristics. And that's what you could expect for a dot plot. Okay, so I really like this. I think it's really nice and straightforward. You're not inundated with a huge amount of information or a whole lot of new definitions, and it gives you really a good chance to practice your dot plots. Now, when I say distribution, what I mean is, how is the data arranged? All right, so the first thing you might talk about is an overall pattern. Right? So you might look at it and you might say, well, it looks really symmetric, or, oh, I noticed that in this pattern, maybe you have, it goes up and then down and then up again. Maybe it's got several peaks is what they could call them. Maybe you look at this one and you say, oh gosh, well, there's a longer tail off to the right, so this one is going to be right skewed. Okay, when we talk about a pattern, we're sort of talking about what the shape looks like. Then you want to look at any departures from the pattern. Right, so say all of a sudden, say this data actually went to 8, and then we had 5 kids in the class that had 8 siblings. And then all of a sudden, your data goes, whoop, that's a departure from the pattern. Or say we'd have a huge number here at 6, right? And sorry, those are not going to be nice, but, and there's another departure. So what you want to mention to people as you're talking about this sort of a thing is what the pattern looks like, but then anything that might be a breakdown of the pattern or anything that's sort of out of the norm. Try describing its shape. Okay, so shape would be symmetric, right skew, left skew. Its center. Okay, so like here, for example, if I wanted to describe this to somebody, I'd say, well, most students in the class had between 0 and 7 siblings, and so the center really would be 3.5. But if I were to actually calculate, where does most of the data live? Right? Most of the kids are going to have siblings over this way, so the center of our data is definitely going to be a lot more in this first half of the numbers. All right, now, until you really start thinking about calculating like something like the center of data using like the mean, which we'll talk about in another section, you might not get real verbal about what the center is, but you might say something like, well, most of the kids have 3 or less siblings, or the majority of the class have 2 or less siblings, or you could even say the most kids in the class have 1 sibling. All right, so that would be a good way to talk about the shape and the center. And then the last one is variability. Variability is how it changes. Okay, and we'll talk more about standard deviation. And if you feel like you're not getting the full description of it, that's okay. Remember, we're just starting this and we're just trying it out. And you're going to see lots of different ways to represent data. And some pictures, you can use better materials to describe them. Then a dot plot might not be the thing. But when we say variability, we mean how different is it from itself? Okay, so maybe there are 2 peaks, right? So that's something very variable, right? Here we could say, gosh, we come down and there's only 1 kid with 5 siblings, no kids with 6, and then back up to one kid that has 7 siblings. That would just be how it changes as we go. Excuse me, I've got like a in my voice and throat. The last one is to mention outliers. Now, this one doesn't have an outlier, but say Betsy Ross was in your class. My kid just did an assignment today on Betsy Ross. Betsy Ross had 16 siblings. Do you see how far her dot is from everybody else? She would be considered an outlier. So if you have a bunch of data and you find that there is 1 or 2 points that are very, very far away from the other points, you might want to mention them, right? You might say, well, we have an entire class of kids where 99% of the kids practically have 7 or less siblings, and then we have 1 kid in the class that's got 16 siblings. that would be an outlier. There's a more formal definition for that you mathematically calculate, but for now, it's just something where if somebody was asking you to describe data and a distribution in a dot plot, that might be something you would want to mention. Okay, so if you have questions, make sure you come to office hours, make sure you get a hold of me. We will meet live on Wednesday. I'm in office hours every day really. But go ahead and try out the homework for this, and if you have questions on dot plots, just let me know. Have a great day.